Hello everyone, welcome to my channel. So first I would like to tell you about myself. So I have around 20 years of experience in automotive, and currently I'm working as a freelancer, and I'm trying to help you through these videos. So not only on wiring harness, I will tell you about the product development from concept to the SOP, how we make. So first I will go through the some comments which I got. So please make a full video of one harness design. So that I will do. That I will do. Sorry, second. That I will do. Coming to the second, with the tools, you want the wiring harness design with tools. Tools, as I know that XC, capital harness, capital logic, E3. So you want with these tools. So to be honest, so these tools are not freely available, and these are the company specific tools. However, I can tell you the process how we start from using these particular softwares, and if you learn the process itself, then it will be more than helpful. And if you go in any company, then it would be more than sufficient. They just want to ask the process only most of the time. However, few of the companies take the tool test also, but if you know the process, then you can manage anyhow. So the same question, that logic and XE. So I will try to get it if it is possible. So I will definitely make. So as you know, I'm coming, I think, after 3 months with this video. This, I think, fourth or fifth video. So I have one request, that at least please subscribe and comments and like the video so that I can get motivated. So whatever information I am sharing, at least it is helping you and it is making sense of making these videos, because you know that these making these all these video takes time, and I have to study and all those things, and I have to make all these, take out the time from my busy schedule. So please subscribe, like, and comment at least, so that I will get motivated for further, videos. So coming to the, our wiring harness series. So in wiring harness series, the first video which I have created, in that there is a lack of video and the screen sharing and the audio. So I will make that video again and will share again, so that these of your two questions will be addressed there. So coming to the today's topic. So today's topic is nothing but which we have already discussed about the component of the wiring harness. So moving to the further. So component required to prepare the wiring harness. So last time we have discussed about these components, but I have discussed these component, an overview. I did not went into the deep. Okay. So as you know, the component required to prepare the wiring harness, there are fuses, relays, wires, then connectors, then terminals. Terminals are nothing but inside that connectors, protective covering. So you can see these core tubes, then clips, and clips would be somewhere. Definitely, these are your grommets, and then other taping and all other things for the protective covering. So these are the components required for the wiring harness. So earlier videos I just gone through the overview of those particular components, but now we will go to the deep dive in those particular components. So first I am taking the fuses. Okay, so this is very critical part of any wiring harness. So we will go to the fuses, and what are the points we are going to discuss with the fuses, we'll see. So components required to preparing the wiring harness, the first component which we are taking, the fuses. Okay. So what is the fuses? Fuses comes under the protection device. So do you think that in protection device is nothing but where your device is, or your component is protecting something. Protecting something means it can protect the wire also, it can protect the device also. Okay. Right now I'm not talking about the fuse. Okay. So protecting device can be fuse, which always protects your wire. What else? The protecting device, fusible link. Okay. What else can be the protection device? Circuit breakers. Okay. So these are the protection devices. We will discuss only one, that is our fuse, which is very critical part in automotive or any aerospace industry, locomotive also. However, in space or aviation industry, we use generally circuit breakers. So I will give you the overview of these circuit breakers also in the coming slides. Then we will discuss what is the fuse, what are the types of fuses, what are the criteria to select the fuse, and few practical example of the selection of the fuse. See, this information you will not get on anywhere. Why you will not get? You can get the definition of all these things, but the practical selection guide you cannot get at anywhere. Okay. This can tell I can tell you based on my experience only. So coming to the first one, so you see, first, what are the protection devices are used to protect the wire, connectors or devices from damaging for the uh, you know sorry by accessing current flow by an overcurrent or a circuit short circuit. So if there is a condition where this particular wire is there and wire strength is only 4 ampere current carrying capacity is having, okay, but if you are passing through from this particular wire is 10 ampere of 10 ampere of current, so it can sustain for like 10 second or 1 minute or 2 minutes. But when you are carrying this particular 10 ampere of current for a long duration, then there will be a situation when it will start burning, okay, due to I square T. You might be aware that heating concept, okay. So heat will dissipate, and when heat will dissipate, then for the long duration, then wire will start burning, okay. So actually any device, circuit protection device, what actually they does, so they save this, protects the wire and connector. How they protects and save the connectors or wire from damaging? They just cut off that particular current, so that if suppose this particular wire is having the 4 ampere of carrying capacity, but you are running 6 ampere or 10 ampere, then it once it will go above this particular current carrying, then it will just blown means it will just disconnect, okay. Fuse will blown, okay. So fuse is nothing but the protecting device which used to cut out the particular connection when there is a specific, the current over current is flowing through that particular circuits. So in this we have there, as I told you earlier, that we have the fuses. Sorry, we have the fuses, then fusible links, and then circuit breakers. Fuse and fusible link are more or similar. Circuit breaker has some different concept. So fuse, generally what happens, it blown. Okay, blown means it disconnect. It blown means the metal strip used to be there, and this metal strip generally burn out, and it disconnect the connection from one end to other end. In fusible link also the same, but when circuit breaker comes, so circuit breaker is nothing but a reset switch. So what it does, it reset, like one is on condition, other one is off condition. So above 4 ampere it will be off. Okay, till till 4 ampere it will be on. So it will reset. So what is the difference between fuse and circuit breaker? In fuse, you have to replace that particular device. What is device means? Fuse itself is a device. I am talking about this particular fuse as a device. But in circuit breaker, there is a knob, right? Okay, so it just on and off like a switch. So when you on the switch, you don't replace the whole switch, right? On and off, you just do the on and off by your hand. Okay, so this is something like that. This is something like that. Circuit breaker is something where you can do the on and off or resetable switches, you can say. Okay, so coming to the I hope the circuit breakers, you got the difference between fuses and circuit breakers. Circuit breaker, there is no need of replacing that particular. It resets, and if you want again that particular connection to be come into the alive, then you have to again switch on that particular. But there is a process of resetting this, and in which condition it can be reset, and what is the region of resetting of that particular. So we will not go into a detail of circuit breakers. You just take the difference that circuit breaker are the resettable switches. Okay, and fuse are the something which blown, and you have to just replace that particular fuse. So now we will see here. So this is our fuse box. Okay, this is our fuse box, and these are the fuses. Okay, so how to develop the fuse box, and how many numbers of fuses need required for one particular vehicle, we will discuss all these things in detail when we will see the fuse box development. Okay, but as of now, you just see that these are the fuses which are inserted in this particular fuse box like this, and we are talking about right now only this fuse box. Okay, fuses. Okay, not fuse box. So if you go with any vehicle development, then there are two things which are very important. One is power distribution, and other one is the ground distribution. If you are understood these two things, power distribution and ground distribution, then your work is done in a schematic generally. Okay, because power distribution decide where your power is going, how many numbers of maxi fuse you have to select, how many midi fuse you have to select, how many mega fuse you have to select, how many mini fuse you have to select. So all these things comes when you decide your power distribution. So we will not go as of now in the fuse development. First we will go the fuse, we will understand. So these are our fuses. This looks like this, and if you can see here, this is the connection from one end to other end. Okay, this is our fuse box sticker. So mostly most of the vehicles you will see that particular, they mention which type of fuse, like accessory fuse or lighting fuse, autopilot, and DC circuit fuse. Okay, horn fuse. Okay, so these fuses, we will understand that how many fuses are required in vehicle. But first we will understand the fuse concept, and then we will see that how many fuses are required for that. So this is the also a fuse box where you can see these are the fuses, these are the relays, these are the fuses, these are the fuses, you can see here. Okay, this is the our fuse box casing. Okay, where we put our fuses and the relays. So coming to the fuses are used for the protection of the circuit components. Material used in fuse generally tin, lead, zinc, copper, silver, and alloy of any of tin and lead. Okay, so anyone can ask this question that what is the material for the fuses. So tin, lead, zinc, copper, silver, and alloy of you aware the mixture of two materials. So I hope this particular slide is good to go. Coming to the second one, where we will see the type of the fuses. I hope fuses you understand. Fuses is a sacrificial device which sacrifices itself when there is a current above that particular specific limit. Okay. Now, what is the type of fuses? So there are three types of fuses. One is blade fuse, cartridge fuse, bolt down fuse. So we will see these type of fuses are described based on the geometry or construction of the fuses. So in this blade fuse also there are six types of blade fuse. One is maxi fuse, ATO fuse, macro 3 fuse, mini fuse, macro 2 fuse, low profile mini fuse. And all these fuses have some specifications, some application. That's why they are categorized like this. So if you see the maxi fuse started from 40 amps, 30 amps, okay, 20 amps. So generally this started from the 20 amps to 30 amps, and it generally a time delay fuse. I will you know tell you the what does it mean time delay fuse. And it is like a high for used for maxi fuse, generally used for the high currents. Okay, like ATO fuse is used for the lower currents, sorry, lower currents. And there are by the colors there are ratings also: 10 red, 50 amp, blue is 60 amps, yellow is. However, you have no need to mug up, because these are the something which you will automatically come to know when you will start working on these. So in this also, like ATO 10 ampere, yellow 20 ampere, clear 25, green 30 ampere. So these are all comes in the six are the type of automotive blade fuse, where comes under the blade type of fuses. Now coming to the cartridge fuse. So cartridge fuse is also a type. Why this type of fuse we use, we will see this thing. And generally if you see, these are the high current fuse, like 20 amps, 25, 30, 40, 50 amps. And these are the time delay fuse also. Time delay, or I will tell you there are two types of fuse. One is fast acting fuse, one is the time delay fuse. Okay, so I will discuss in coming slides what is the fast acting fuse and what is the time delay fuse. Then low profile J case in this cartridge, and M case fuses. Okay, there is also unslotted, slotted, and there is a male and female concept is also there. Then these are the colors. So coming to the next one, I think in blade fuse we have the six type of fuse, and in this cartridge we have the main two types: J case, low profile case, M case fuses. Now coming to the bolt down fuse, okay, we will understand why and where this will be used in the coming slide. Don't worry about that thing. First you understand the type, then we will go. Then bolt down fuses. So bolt down fuses, you might have seen this type of fuses are called bolt down fuses, and they are always time delay fuse, or slow blown fuse also we call. And they are comes into the mega, midi, and Z case. Okay, and what is the bolt down, why they are called? Because here generally we put one bolt in the J case. I will show you how their casing has to be done in the vehicle. So these are the bolt down fuse, and if you see their MIDI fuse are something which started from 30 amps and 150 amps, but mega fuse are always higher current fuses from 80 to 500 amps of fuse it goes. Okay, generally mega fuse are used for the starters for higher current, and the alternators, and Z case fuse also. So these are the type of fuse. So we have seen the type of fuses where we have seen blade fuse, then cartridge fuse, and then mega fuse. Okay, you just understand these types first and you get this idea ki what are the ratings and what are the how they look like. You just understand this thing. We will go one by one in detail what is the meaning of this. So now I was talking about two things. Okay, one was the I was talking about fast acting fuse. Other one I was talking about the time delay fuse. Okay, so these three types of fish which we have seen earlier, so these are categorized on these types based on the characteristics. So one is fast blow fuse. Fast blow fuse is not nothing but fast acting fuse. Slow blow fuse is nothing but the time delay fuse. So first we will understand and then we will go one by one of the blade type fuse and all this. So fast blow fuse, this type of fuse are designed to immediately, sorry, I have not written the full statement, but I'll tell you what does it mean. To act immediately or to blown immediately. Okay, to blown the immediately. Okay, Malab, what does it mean? Blown immediately. So there is a time opening of one particular fuse. Okay, so if the particular fuse is not taking any time to blown, okay, like suppose 0.35 second it has to blown, okay, generally, okay, fast blown fuse, so it will blown in that particular duration itself. But when you come to the slow blown fuse will take some time, it will withstand for some time, like 1 second or 10 second. Okay, so first fast blown fuse are nothing but they are designed to withstand for one particular to blown immediately, and these fuses do not withstand on rush current or peak current. So what does it mean? So suppose one continuous current is having, okay, one example we will take, one example we will take. So 60 watt of light example we will take. 60 watt light, okay. In 60 watt light, headlamp, okay, headlamp we take example of headlamp. Okay, so this generally the power required is 60 watt. So I have told you one thing, when P is equals to VI, and we take the one example of 12 volt system, 12 volt for power, for car, then P is 60, then I is 60 upon 12, and this is our 5 ampere. Okay, so 5 ampere is what? This is the continuous current. We got the continuous current or normal operating current. Okay, this is our 5 ampere. Then what is the rush current or peak current? So what is the rush current or peak current? When suppose there are some inductive or capacitive load, okay, inductive or capacitive load, then you have seen the transient characteristic of current. Okay, so where the peak will go and then it will settle down. So for capacitive and inductive load, what happens? The current will go with the peak and then it will saturate it on this. So this peak current, this is called peak current, transient current. Okay, so what happened with the slow blow fuse? They don't withstand on these currents. Okay, so if you take the example of headlamp or any other, so these are continuous current is coming 5 ampere, so where you have no need to think about this rush current or peak current. Okay, you can use generally the fast blown fuse, because we don't want that it should withstand for any rush current or peak current, because we do not have our component or device in such a way. But when it comes starter motor, okay, So starter motor, you might have seen, motor is inductive load, okay, inductive load, and its peak current goes till 300 amperes or sometimes 750 amperes when it start the engine, okay, when it start the engine, and then it goes down. So in this condition you cannot put your slow blown fuse, sorry, fast blow fuse you cannot put. Okay, why you cannot put? So suppose my normal current, suppose, sorry, my normal current is 300 ampere, okay, and my peak current, sorry, my peak current is 750 amps, okay, and you have put the fuse of, as of now I am just taking example, okay, sorry, 300 into 0.25. Right now you just don't focus on calculation. I will tell you how to find out this calculation. So my current, my this value is came fuse. Suppose I am putting the fuse of 400, fuse rating of 400 amps. Okay, but my peak current is going 750 for suppose 1 second. Okay, this transient current or peak current, this particular T. Okay, so in this case, your fuse is going blown within suppose 0.3 second. If you have put the your fast blow fuse, then you understand, like 750 amps it is going, 750 amps it is going, then what will happen? Your fuse will be blown immediately. Then again you will replace, again it will blown, again it will go, again it will be blown. So what will happen? It is not protecting your wire, it is making nuisance. So when there is a chances of rush current or peak current or transient current, whatever you say, then in that condition you have to put the slow blow fuse. Okay, so slow blow fuse kya hai? These are the fuses are designed to withstand for rush current or transient current for a movement or for some duration. Okay, they do not blow immediately. Okay, like our fast acting fuse. I hope you got my point, what I'm trying to say here. What is fast blow fuse? What is slow blow fuse? Fast blow fuse will blow immediately. Slow blow fuse will take some time to blow so that your peak current, it can withstand to that peak current, so that it does not make nuisance for the consumer, that again and again you are going to change that particular fuse. I hope I'm clear. So we will go with the slow blow fuse. So slow blow fuse, first I hope you understand the uh, what is the slow blow fuse. So slow blow fuse, in slow blow fuse we have the blade type of fuse. In blade type of fuse we have the 6 fuses. Okay, so what are those 6 type of fuse? Maxi fuse, ATO fuse, macro fuse, mini fuse, macro fuse, low profile fuse. These all are comes under the blade fuse or slow blow fuse. But when you go to the slow blow fuse are those fuse which take some time and they can withstand to that particular transient current or rush current, and these are comes in this type of casing you can see here. Okay, and which I told you that cartridge fuse and midi or mega fuses or bolt down fuse. Under bolt down fuse we have seen midi